anybody not doing product rule? Okay, so you're all using product rule, right? All right, then I'll do method too while you're finishing that up. Hopefully you got the same answer that I got. What do you mean? You did?
Yeah.
Good.
Wait,
Yeah, get up there. You're such a coward. Well, you're afraid to write. You got the right answer, right? So what's the problem?
I don't know what the problem is.
Wait, so you're suggesting you maybe did it wrong but got the right answer?
Yeah.
The odds of that are astronomical.
He's an astronaut.
Oh, now you're taking my seat. That's cool.
I'm keeping it warm for you.
He's the new Dante.
I could live up to it. I don't know, blue jacket. What size is that one here? So if it gets warm in here and you need to take off the jacket, where would you put it? Under your desk or something?
Maybe for
Around my chair. I'm just saying, you know. Quarter's gonna end soon, grades are coming out.
I win.
Sorry. Absolutely not, I'm not threatening anybody, we're just having a conversation. Just two guys sitting in class talking.
Where'd you get it?
Two bugs.
Two brothers just chatting about a wicked jacket he's wearing, man. That happens to be my size.
And my style.
most days.
Do we want to post this right?
Yes, watch Bill and Ted's together.
There's a double feature.
The problem is if you, there's the second one is with them, right? If you've never seen the movie that that's based on, you don't get a lot of the seven seals, you're right.
I think I did something else.
What?
They're all barking.
Same answer.
Watch Seven Seal, watch Bill and Ted.
Seven seal is in
All right.
1960.
Let's make sure that,
I don't think I edged it.
but she got the right answer.
Yeah, but
All right. Let's see what he did. So this is, once you start this derivative process, you want to label it as f of x so that we know where that came from.
It's 19x, not.
This should be a 19?
Yeah.
Yeah. Oh, it's 19.
I thought we.
Okay.
There you go.
So this is the first function times the derivative of the second. Derivative 4x squared minus x minus 9 is 8x minus 1. Well done. This is the second function times the derivative of the first, which is 3. So his calculus is good. Where he screwed up was on the algebra. But that's not the end of the world. Multiplied out the binomials. 24x squared minus 19x plus 2. And then multiplied out the last terms. Got that, combined like terms. And sure enough, we have the same answer. Okay. Two different methods to solve the same problem. In that case, you don't have to use the product rule. You can multiply it out. It's entirely up to you. However, you will start to realize as the problems get nastier that the product rule is going to be the way to go. Questions on this? Anybody have any problems with it? I'm guessing more than likely, if you made a mistake, it's probably in the algebra somewhere, not in the calculus. Question?
Yeah, I have like a. This is not really paying this problem, but what if there was another thing you multiply by? How would you use method one? What is like multiply through things?
I'm not going to answer that because it's something we're going to talk about later. So you want to know if you have the product of three things?
Yeah,
How you handle that?
Yeah, I just did method 2 in the homework. That's the only way that I knew how to do it.
Okay.
Is there is an easier way to do it with?
I wouldn't call it easier, no.
Oh,
No.
okay.
There is another way to do it that involves taking the derivative of certain things in certain orders, but in a case like that, what I would do is let's suppose the other term was something like x minus 4. I would combine two of the terms, take the two easiest ones to combine, like maybe multiply x minus 4 times 3x minus 2, get another term, and then do product rule with those two terms.
Okay. That
So
was
reduce 3 to 4, or reduce 3 to 2, and then just do product rule. Okay? All right, let's finish up with this lesson then. We've got some, oh look, we got the same answer, good. We got some trig functions going on here. We already know two derivatives of trig functions. We know that the derivative of sine is cosine, and the derivative of cosine is
Negative.
good. And you'll screw that up somewhere along the way, but that's okay. The thing that will screw you up is where does the minus sign go? Does it go with the, yeah, anyways. Here are the other four. Like I've said many times, I'm not a big fan of memorization. So even though I'm going to give you those, I just gave you those four, and most of you are going to write them down and memorize them, I still think it's part of my responsibility to show you where those came from. They didn't just magically appear out of nowhere. There is a method for figuring out what those are. By the way, helpful hint, because I know where we're going to eventually, one thing that you might want to start doing is get yourself some note cards and start making some note cards to help you generate information. It's a lot easier to generate note cards as you move through the course than in April when we start reviewing and you have to go back through all that material to make note cards. But again, it's entirely up to you. There's also some good apps. There's also some good flashcard apps that you can use. So I'm going to show you where one of these comes from and then leave the rest up to you. We don't need to derive all of them, it'd be a waste of time, but I will show you, I think I do the tangent, I'm not sure. We'll see in a second. Okay, everybody got it?
Oh, no, can you do one second? One more.
Notice the functions that begin with c have the minus signs. The derivative of cosine, negative sine. The derivative of cotangent, negative cosecant. The derivative of cosecant, negative blah, blah, blah. Okay, so that's one way that might help you. If you're taking a derivative of a trig function that begins with c, you'll have a minus sign there. Now we're good? Okay, so here is the derivative of the tangent. So I started by rewriting the tangent as the sine over cosine, and now that we've done quotient rule, we can go through and take the derivative of that function. Instead of me just clicking on the next screen, or the next thingamajobber there, what's the derivative of sine over cosine using the quotient rule? Who's feeling saucy? Greg, go.
I was just gonna say it's cosine x over negative sine x, but I don't think it's right.
No, gotta use quotient rule.
Yeah, that's why I put my hand down.
I understand. Anybody else? Go.
Cosine x times negative, no,
Yeah.
negative sine x, no.
Let's take it from scratch. Okay. The rule that I showed you yesterday, instead of just memorizing the formula, like I said, I start with the Gazinta bar. What goes on the bottom? Good, cosine squared. Take the denominator and square it on the bottom. And leave it alone, don't do anything with it. Take that denominator, move it up to the top. So you started strong, Oliver. Now I multiply that cosine by what?
Cosine.
The derivative of the numerator.
Yeah.
So since I took the denominator, I then have to pair that up with the derivative of the numerator. What's the derivative of sine? Cosine. Minus, parentheses. I used the denominator already, now I have to use the numerator. Times
Negative sign.
negative sine. That is really sloppy math. That's better. Okay. Which turns this into cosine squared x plus sine squared x all over cosine squared x. What's cosine squared plus sine squared?
1.
Okay, so I'm going to get rid of this and bring up the other stuff here. So then there's the fancy stuff there. I threw in that extra step for those of you that are still a little confused. How do I get the quotient rule? Square the denominator on the bottom. Bring the denominator up to the top, multiply it by the derivative of the numerator, minus, big parentheses, the numerator times the derivative of the denominator. Okay. You probably don't need this step because you're all pretty bright. Get to that, and lo and behold, that's where the secant squared comes from. Okay, cosine squared plus sine squared is one of those trig identities you should know, which equals 1. Every one of those other 3 trig identities would be done the same way. So if you were doing secant, for instance, you would write secant as 1 over cosine, do the quotient rule, you get your answer. Cotangent, cosine over sine. Which one did I forget? Cosecant, 1 over sine. Okay. Any problems with that? Okay, good. So I'm not expecting you to derive each one of those things. Eventually, through using the derivatives of the trig functions, you'll learn them eventually. But there's all 6 and we're good to go. Higher order derivatives. Okay. Real simple. Let's suppose I start, and I'll click through some slides in a second, but we can address it real easily. Suppose I have x to the 4th. We'll call this y. What's y prime? 4x cubed. Good. Now, what's y double prime?
12x squared.
How about y triple prime? How about y fourth prime? 24. How about y fifth prime? 0. Y sixth prime? 0. And you see eventually what happens when you're dealing with polynomials. These are all called higher order derivatives. Anytime you go higher than just a single derivative, you get another function. Okay? And sometimes, eventually, it will reduce to something where you get 0 and it just keeps being 0 after that. What I want to, and I don't think that's a difficult concept. Why isn't my clicker working? There we go. I don't think that's a difficult concept, but what I do want to talk about is the physics. We've already talked about when you take the derivative of the position function, you get the velocity. Using higher order derivatives, if we take the derivative of the velocity, then we get the acceleration. And you remember this from physics. Do you do any of this calculus in physics? None at all. So you never use the word derivative. You were just given, you didn't talk about the relationship between velocity and acceleration. Okay, well, now we can tie in some physics here. Some calculus into physics. Okay, so we start with position. The derivative of position is the velocity. The second derivative of position is the derivative of velocity, is the acceleration. Anybody taking the higher level physics? Do you happen to know what the derivative of acceleration is?
Not yet, we didn't get to it.
Didn't get to it yet? Okay, you will. I believe it's jerk. But you'll find out. I think that's what it's called. Which we're not going to do anything with. It's like a fast fact, in case you're wondering. You know, you're sitting there thinking, gee, I wonder what the derivative of acceleration is. Yeah. A jerk.
What's the derivative of jerk?
I knew somebody was going to ask me that. I don't know. Siri,
I didn't get that.
well, because I didn't say anything, you idiot. What's the derivative of jerk?
Okay, give me a moment. Here's what I found on the web for what's the derivative of jump.
Jack.
I don't like that accent.
Sorry, that's my fault. Jerk, also known as jolt, surge, or lurch, is the rate of change of acceleration. It doesn't say. Yeah, you try taking
It's like
derivative.
continuing.
I don't know. I don't know. Anyways. Okay, so blah 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 blah. Third derivatives. Here's. Obviously, you're not going to write this down, but I wanted to show you what happens with notation as you continue to take derivatives. For the most part, we usually don't go any higher than maybe a third derivative. Realistically, we do first and second derivatives, but occasionally if we're feeling saucy, we might work in a third or fourth. But the notation changes. The y primes you see after you go to the third, you switch to the exponent form. So that's the fourth derivative of y. These, same thing there, y prime, or sorry, f prime, f double prime, f triple prime, f quadruple prime, all the way up to n. This is the one that gets a little bit weird. So in Leibniz's notation, he decides to do the second derivative by putting the 2 on the d and the 2 on the x. Okay, still a second derivative. That's just the same thing as that, but then this last column pops up occasionally. I don't even know who's responsible for this notation, but you just change the exponents on there again. Okay, so notice that if you see y to the fourth, that's not y to the fourth. That's the fourth derivative of y. Okay, we're done.
Would it be in the parentheses like that, or would it just be?
Probably a safe way to write it would be to put it in parentheses. Okay, everybody read it? All right, good. Let me stop the recording and then we'll look at some